Hey everybody, welcome to our second day of 5.3. All right, I hope you had a great break. I hope that you got yourself rested and are well ready to get yourself going on chapter 5 again. So let's start with a warm up to get ourselves going again and remember what we've been doing. So let's hear in the problem. I have each side of a square is 2x plus 5 inches long. Write a simplified expression for the perimeter and area of the square. All right. Well, considering what I would have as a square, all right, so just think about any square, all right, and if one side is 2x plus 5, remember a square has all four sides exactly the same. So for perimeter, I just add up all the sides. So I could do 2x plus 5 plus 2x plus 5 plus 2x plus 5 plus 2x plus 5, and just add those together. The other way to do perimeter is just 4 multiplied by the side for a square. And then I can distribute. So either if I distribute the 4 or if I add up 2x plus 5 4 times, I end up with 8x plus 20. And then that will be my answer, but notice how I wrote my answer. All right, you put the expression, which is called a binomial because it has two terms. This binomial has to be in parentheses with a label on the outside. Okay, that's technically what it should be. If you forget the parentheses, that's not going to be a big deal, but just kind of think about that for the future. And then consider, now that's my perimeter. If I were to do the area, remember area would be length times width, or for a square, it's just one side squared. So then there's the area. Now I want you to consider, how do you solve this? Now understand that this is not possible, right? Exponents do not distribute. So if I am going to multiply 2x plus 5, I have to square 2x plus 5, I have to multiply by itself. So I need to cross off that 2, and I'm going to write down another 2x plus 5, and now I will FOIL that out. If you follow this process, I guarantee you're going to make less mistakes in the future, because again, exponents do not distribute. So I FOIL that out, first, outer, inner, and last. I end up with 4x squared plus 20x plus 25. In parentheses, that's a trinomial, 1, 2, 3 terms, and area is in inches squared. So then that would be my answer for the area expression. In red, I have the perimeter expression. All right, so just reminding you of adding and multiplying polynomials like we did last year. All right, let's see what else we got. Here's today's lesson. Add, subtract, and multiply polynomials, our second day of this. But notice here we're going to use a graphing calculator to add, subtract, and multiply polynomials. So let's look at an example. Here's our example. Since 1980, the number W in thousands of United States wells producing crude oil and the average daily output per well, O, in barrels, can be modeled by, here's W of T, here's O of T, where T is the number of years since 1980. Now, if it says W is in thousands, remember that means that this number is not 548. That number is 548,000. This number is not 10.9, but it's 10,900. And this number is really 575, negative 575. Now, these numbers are exactly as is. That's simply 15.4, and that is really negative 0.249. What I'm trying to do is write a model. So I'm going to write a model for the average total amount, T, of crude oil produced per day. And what was the average amount in 2000? So first off, let's start by writing that model. Now, total amount, if I have the number of wells and the daily output per well, I have this many wells and this much output per well. To find the total, I simply would multiply them together. All right, if I had 15 wells and every day I got 40 barrels, I would do 15 times 40 to find the total in the United States. So our total amount, T of T, I'm going to use a different page to make this easier for us. All right, our total amount is simply going to be this. There is our model. Remember, our question was to write a model, right, which means write an equation. So if I look up here, I have this is an equation. T of t equals W of t times O of t. You might be thinking that seems too simple, but guess what? That is an equation. That is a model. Do we all know what W of t is? Yes, it's right there. Do we all know what O of t is? Yes. All you had to figure out is basically you're telling me I need to take this equation times this one, and that's it. Instead of having to multiply and FOIL it out, I'm like this answer. Just simply write that. Now the next thing we had to do was we had to figure out how much oil, what was the amount in 2000. So in 2000, realize that that means I am talking about 20 years that I'm going to go for. To do this problem, I'm actually going to use the calculator. So basically all that means is I'm going to put a 20 in for t. Well, instead of putting 20 in for t and t and t and multiplying that all out, or foiling this and multiplying it out, putting 20 in, I'm going to let the calculator do the work. So what I'm going to do is I'm going to go into y equals, and I'm going to make this happen. All right, so I made y1 be W of t, and y2 is O of t. All right, so let's go back here. I'm going to make this one y1, and this equation y2, and I'm going to make the calculator do the math for me. And so what I was really going to do is I'm going to put in y3, I'm going to make this equation. I'm going to have y3 be t of t, y1 is W of t, y2 is O of t. And so to do that, I'm going to go right here. Now, if you have a newer calculator, a calculator that looks like mine with the colors, you have an advantage. It has a shortcut. So the shortcut is alpha trace. So why don't you try that with me right now? Push alpha trace, and does this list show up? If yes, you have a newer calculator, a newer software, and it works. There's the bell. So you can simply type in y1, all right? So you can do number 1, and then multiply it by, and again, I can go alpha trace and get y2, okay? If you don't have that function, what you do is you hit vars, which is short for variables. Vars, I want a y variable, so I'm going to push the right arrow. I want number 1, a function, and there's y1. And then I'm going to multiply it by, again, vars, y vars, function number 2. Right? Again, if you didn't catch that, there's an alpha trace is a shortcut to get to y vars. All right? But if that doesn't work, you have vars, y vars, function, and here's your list. Okay? Now, I only want to graph the total. So what I'm going to do is I'm going to go up here and not have to waste time. I'm going to hit enter and enter. And now notice only y3 is highlighted. So the only thing that's going to graph is y3. All right. Now, what I'm going to do here is before I hit graph, I'm going to go to window and think about my window. All right. X minimum. X is time in years. So the minimum of time is 0. The maximum time, well, I'm trying to count 20 years, all right, but I want to make sure that 20 fits. So I'm going to just go to 25, and then from 0 to 25, I'm going to count by 5s. My Y minimum, all right, Y is in this case the total amount of oil. Well, the lowest that could be is 0. The maximum, well, let's think about this. T of t, if I were to multiply these two functions together, the y-intercept would just be the two constants multiplied together. So I'm just going to multiply right now. 548 multiplied by 15.4. Again, think about it. If you multiply these two together, the y-intercept will just be whatever this constant is multiplied by this constant. And that is that number. So 8,439.2. All right, so just to be safe, I'm going to make that go to 9,000, and then I'm going to count by thousands. And let's hit graph. All right, now I don't know what shape this is going to be, all right, because think about it. This is a quadratic, and this is linear, so my function should be cubic. X squared times x would be x to the third, right? But I don't need cubic. I just need to know where 20 years is. So I'm going to go second trace, and number 1 is I want to find a certain value. I'm going to type in when x is 20. There it is. So here's the work that you would need to show right here. T of 20 equals 5585.12. And the answer, remember, was in barrels per day. So it's amount in thousands. So number, and then this was barrels, all right, per day. So then that's going to be my answer. But remember that W was listed in thousands. So that means I need to add 3 more zeros onto this line, or 3 more positions. So really, that is my answer, is the number of barrels per day. Okay, so that's how we're going to use this. So instead of having to take these 2 equations and FOIL them together and take that time, we can plug them into the calculator, let the calculator multiply them together right here, plug in 20, make sure my window can fit 20, find the answer, and we have it. That's going to be much easier than trying to FOIL. All right. This would be the homework assignment for this lesson with 1 extra credit question. Good luck and have a great day. Welcome back to school again.